This is a really good example of a large dataset delivering interesting information when plotted graphically. In this case, each data point is an earthquake in the past 15 years of category 6 and above on the Richter-scale, plotted in autograph with a world map in the background. Let's see how this was done and what mathematics can be learnt along the way. First of all, we need to go and find the data. This is my TSM Resources website, and if we go to Mathematics Links and scroll down to the Probability and Statistics section, there's a data link here, and the data we're looking for is the world earthquake data. So this site's rather good because the defaults are just what we want. All earthquakes of category 6 or above, so there's a log scale there to discuss, of course, from 2002 onwards. So we'll just submit a request. Right, here it all is in an HTML format, which isn't always what we want, but we want to get this into Excel now. So I'm just going to select from here and drag down, but it's too far to drag all the way, so just remember that when you press the Shift key, that determines where your selection finishes, so we want to finish there. Then we right click and copy. So now we want to open up Excel and right click, paste. Doesn't matter which of these we do because the result's the same. It puts all the data into one column. It's quite a common problem, this. So how do we get out of it? First of all, we want to get rid of row number 2 because it doesn't contain any data. So delete that. Select the column A, go to Data, Text to Columns, choose Delimited because it's the space that is splitting up these columns. So go to Next, Space, and there it all is nicely sorted out, and finish. What we want to plot is the latitude and longitude data, so we'll just grab those two columns and copy. Marvellous. So now we go back to autograph. Now that's the one I did earlier, but here's a new page, and right click, enter XY data, right click, paste, use the column headers and plot. Okay, these appear to be the wrong way around, so we just need to double click on that and swap the axes. Now values of longitude and latitude are in degrees, and they go from -180 to +180 along this axis, or -90 to +90 along that. So we basically want the numbers not to go in hundreds but to go in 45s. That'd be much better. So 45 there. Now we need to go and find a picture. So we go back to the web and a new page, and let's search for world map. Now what sort? Well, we want Mercator's projection, definitely, because these are rectangular coordinates and the North Pole represents all the space along the top. So that's perfect. What have we got here? That one looks okay. So view image. Just bear in mind the copyright nature of some of these images, and right click, copy, back to autograph, right click, paste. Double click on that to give it a bit of transparency, usually about 20% or so is pretty good. Then OK. Now we just need to stretch this out. Now what about 0 longitude is of course the Greenwich meridian, so that needs to go through Greenwich, which it just about does. 0 latitude is the equator, of course, so we need to shunt the map up so we get the equator, which from my geographical knowledge is round about there. So we can look at this in the original one that I did before, where I had a bit more time to get it together. You can see all the trouble spots around the world accurately presented. So the real power of statistical analysis is converting that into that. So I hope you found this a useful way to put a large data set to work.